Isn't it lovely to have a summer or a spring birthday party outdoors under a tent like this? And this is a threefold birthday party. First of all, this is the as close as we can get to a 100th birthday celebration for William Tutte. It is the 50th anniversary of the Faculty of Mathematics, which gives us a time to celebrate. And it's the 60th anniversary of the University of Waterloo. So it's a mega birthday party. My name is Stephen Watt, and I serve as the Dean of the Faculty of Mathematics here at the University of Waterloo. I'm going to read some notes here for a good part of these remarks because there's several, I think, important things that we want to say, and I don't want to miss anything out. So please forgive me for not being entirely ad lib here. I much prefer to sort of roll more loosely, but there are some important things to say here. And before we begin, I'd like to acknowledge that we are on the traditional territory of the Neutral, the Anishinaabe, and the Haudenosaunee peoples. I would also like to acknowledge certain special guests who have joined us today. I'd ask whether, for those whose names I call out, to please stand so people get a chance to bask in your presence. That wasn't part of the notes. Okay, so Regional Chair Ken Sealing. Dave Jaworski, Mayor of the City of Waterloo. And more importantly, math alumnus. Okay. Barry Verbanovic. Barry? Peter Rowe, Councillor, Ward 2, Township of Wilmot. Peter? We also have here today, I believe I saw Bob Lemieux, Dean of the Faculty of Science. Is Bob here? Okay, Bob's not here. And we have several other senior level administrators here. I believe I saw Sally Gunts from FAO here earlier. Sally, are you here? There. All right, so thank you. It's inspiring to be in the presence of so many incredible members of our Waterloo Math community, our friends, our faculty, our students and staff, and some of our alumni. We've been brought here today by a common purpose, which is to recognize the work of one of the Faculty of Mathematics' most legendary, albeit immensely humble founders, William Tutte. More importantly, we now take some time to reflect on the pathways he forged, not only throughout the campus, but around the world. I find it fitting that we've chosen the occasion of Tutte's 100th birthday to provide the recognition he so richly deserves, not just for his extraordinary life-saving achievements in World War II, but also the instrumental role he played in establishing the identity and reputation of the Faculty of Mathematics here at the University of Waterloo. This is a faculty that, I should add, is also celebrating its significant milestone, its Golden Jubilee. That's the 50th anniversary we're talking about. It's also appropriate that as one of our visionary founders, we should celebrate these two events together. So we've chosen to name the road that's out there that leads off the ring road into the cluster of the three math buildings. We've chosen to name that road William Tutte Way. Now, we're an innovative university, and we're breaking with a tradition of not actually naming our roads. So the road that goes around the ring of the campus here, that's called the Ring Road informally. And this road out there used to be known as the road that leads to the loading dock. This is a much better name. This is the first time there will actually be a named road on the main campus here, on this main campus of the University of Waterloo. So this is, I think, it's not a big road, but it's a big occasion. Now, universities are much more than collections of roads and buildings, books and equipment, and so on. These are places for inspiration and ideas, for discoveries and breakthroughs, a place where curiosity is ignited and possibilities are opened up. This was especially true for Tutte, who from a young age of 10 was determined not to let opportunities and prospects afforded through education pass him by, no matter the barrier. In fact, each path that Tutte took in life, education played a fundamental role. You're going to hear much today about Tutte's role, his heroic role in World War II and the intellectual achievements in graph and matroid theory. You'll also learn about his contributions to the four-color problem, squaring the square, and how his work continues to provide the scaffolding on which we hang our work in cybersecurity, privacy, and many other subjects. But for the next few minutes, I'd like to focus on Tutte the man, Tutte the person. Now, when we retrace the steps of Tutte's educational journey, well documented by Professor Dan Younger, I should say, there's always a moment of dread when I realize that things might not have turned out this way. If it weren't for the acts of generosity at a few key points in his life, some sort of philanthropic investments by those who couldn't have known what would happen, the world would have been deprived of William Tutte's mind, and arguably, if we think back into the past century, it could have ended up being a very different place. You see, Tutte was born in 1917 to an English family of what we might euphemistically call modest means. His father was a house gardener, and his mother was the cook. Though he was a gifted young student, the children of his community often ended their studies at age 9 or 10, and then went on to work, something which is hard to imagine today, 100 years later. Could you imagine your 9-year-old son or daughter not being able to go to school and then step into a fulfilling, to have all the opportunities open to them, to have opportunities closed because they had to go and work because the family couldn't afford to do otherwise? Well, that was the situation that Bill Tutte found himself in. Now, this is the first point where community generosity helped William Tutte. He competed in a math test, a competition, if you would, and he achieved the top score on that test. And it was such an event that everybody in his village got the day off. He got a scholarship to go at, well, only half the day off. But nonetheless, so talk to our mayors over here, okay, when the math contest results come out. All right, so in any case, there was a problem. The school to which he obtained the scholarship, this community scholarship, was 18 miles away. The family couldn't afford to send him, by some transportation there. It was too far to walk. What to do. In the end, they decided he'd have to forego the scholarship. But through his tenacity, the next year he entered this competition again. Again, on this test, he got top marks, and this time he also got the scholarship, but there was an additional piece. The scholarship also included a bicycle. And this allowed him to ride back and forth. Now, 18 miles is not nothing, all right? So that's 36 miles a day back and forth to go to school. That schooling led to entry into Cambridge and acceptance at Trinity College. And I would say the rest is history, but there's more to it than that. Now, I think I've skipped ahead here, so I'm going to skip some of these lovely notes. The fact that, so when he went to Cambridge, it wasn't really just showing up and that was that. There was also a full set of scholarships that were required in order for him to be able to attend. And so that's a second point where things might have gone another way if he hadn't been able to afford to go to Cambridge. So whether it's through tenacity or sheer stubbornness, he succeeded. Now, Okay, so now, as we move forward, I think that we should acknowledge here how these undergraduate and graduate years were opening new paths, some of them well-trodden, some of them actually new explorations in William Tutte's mathematical career, as he was exposed to new ideas and new people who were quite different, perhaps, than the ones he'd be with every day in his school and then in his village. So I'd like to pay tribute to those who have ensured his academic journey was not cut short by helping him along the way. Nonetheless, he got there, through the power of his brilliance and through his own. So he earned his way there, is the main point here. Now, perhaps it was this notion of having been received that trust and support to enter his studies that led to this sense of duty that drew Tutte into Bletchley Park, where through his mathematical approach he was able to crack the code that no one else had been able to crack. This is not some of the easier codes that we watch nice movies about, but there are other nice movies that talk about this. I think it was the Lorenzo SN40 code, I believe, was the code that he was able to make the steps to break. And this was not just the code that was used to order more sandwiches for events in the Nazi Party. This was the code that was used by the High Command to guard the most sensitive messages. So this was really instrumental in the war. His yearning for knowledge throughout his career was as strong as its conclusion as it was in the early days, going back and forth those 36 miles to his school. It's my hope that the students who make their way along William Tutte Way will have those same opportunities. Now, the road we have named in his honor is as humble and modest as its namesake. Well, I would say that this road is deservingly modest, but Bill was not deservingly modest. He could have afforded an ego as large as the mythical Math 4 building. But that wasn't him. All right. So to ensure that Tutte's achievements aren't lying only in the past, but also in the future, we will be doing something else as well as naming this road. We will also be creating an undergraduate scholarship in his honor, and this will be awarded to the most accomplished student each year in the area of combinatorics. This selection we take the selection of our scholarships very seriously, and indeed in this case we will be awarding the scholarship in years where there's a deserving recipient. But we won't necessarily have to award it if there's not someone who meets the bar that's set by the selection committee. So you may have wondered why I was talking about scholarship so much at the beginning, and this is why. All right. So we can't grant everyone a half day off, sorry, when the scholarship is awarded, but we can certainly be proud of the recipients and our future alumni who go out there and carry the reputation of the university and also carry William Tutte's name out into the world explicitly, as that name is on all of their CVs they send out as having received this William Tutte Scholarship. And indeed, when they become famous in their own right, then that will bring back reputation to the university. All right, so I think that's where I'd like to end this portion and just say that the way that we treat our students and we like to give them the same opportunities that were offered to William Tutte, and we should be so lucky as to have any outcomes that are even remotely close. But now, I joined the university here after William Tutte was no longer with us, but I understand that he was a marvelous individual and colleague, and I wish that I were here earlier to have enjoyed his his friendship and collegiality. So with that, we're ready to begin our program. Thank you. Now, it's my pleasure to invite to the stage Waterloo's inaugural alumnus, and also, by the way, a graduate student of William Tutte, Ron Mullin.
Strokes can be inconvenient. This morning, Dan Younger mentioned the problem of squaring a square and mentioned that this had been solved by Bill and a group of 3 other people at Cambridge. He also indicated the significance of that. I had planned actually to mention this because it somehow relates to this monument that is sitting beside us here. And what Bill was well known for with his other group of people at that time was solving a problem called squaring the square. So I want to tell you just how they came across that problem. I don't think I'll go into a lot more detail, but also how it relates to what is on the podium here. Excuse me, my memory isn't what it used to be, so I'm going to have a crib sheet. I just remind you that the 4 people in the group that Bill was in were undergraduates at Cambridge. They are Bill, of course, R.L. Brooks, C.A.B. Smith, and H. Stone. All of them, except for Tutte, were in math. Of course, Tutte was in chemistry, but his love was for math. And they became lifelong friends and all became very, very famous. They all enjoyed puzzles, and I think a lot of people do, and especially mathematicians like puzzles to work on. In 1936, they were reading Canterbury Puzzles by H.D. Dewdney. In it, they found a puzzle called Lazy Isabel's Casket. The casket's lid was a rectangular sheet of wood and of specified dimensions, and it was totally covered in smaller, non-overlapping wooden squares, all of which were of different sizes. The problem was to determine the sizes and the arrangement after seeing the finished product. The answer was given in the book, and Dewdney claimed that this was unique, this solution, and he wrote that he could not, now this sounds a little bit about another mathematician being mentioned earlier, cannot here show the subtle method of learning that proves the uniqueness. So he was essentially writing in the margin, I know how to solve this, but I can't tell you. I prove this uniqueness, but I can't tell you. Arthur Stone saw that this could only be true if it's not possible to divide a square into smaller squares, all of different sizes. Because if you can do that, you can take the smallest square in the rectangle as given and replace that by the square divided into smaller squares. So if this claim was to be true, then Dewdney must have proved that there were no such rectangles, amongst other things. Well, they weren't so sure of this. They sort of doubted it, and they decided they would try to create a squared square. Well, in 1936, which is the year they were working, there were some publications already about squared rectangles. And for example, 32 by 33 unit squared, or rectangle, I should say. The units don't matter because you can blow these things up or shrink them, which is important in what they did in showing that the uniqueness relied on this problem. The rectangle was 32 by 32 units with 9 squares with sides 1, 4, 7, 8, 9, 10, 14, 15, and 18 units. This is now known to be the rectangle with the fewest number of component squares. All the known rectangles were created by ad hoc meanings that is without any unifying theory. In other words, you look at some small cases or something, but you haven't figured out the theory that holds these things together. Well, the team of 4 developed some methods for doing that, but they found there was no insight in doing that. So they decided they were going to try to maybe convert the rectangles into some sort of pattern. And they tried various patterns, but what they finally did is they put points on they thought of it as a horizontal, bunch of horizontal lines, put points on those lines and join them together if they lay on the same square. That's technicality that we shouldn't worry about. But they also learned how to associate that with an electrical circuit, which is what Dan was mentioning this morning. And with knowing this, they could now use the methods which were established in electrical engineering. This, by some coincidence, the process they were using, the network, actually satisfied Kirchhoff's laws if you used unit resistance on all of the sides. Well, they made a lot of rectangles this way, but none of them could fit together in a pattern that would make the type of square that they wanted. But one of them broke up the puzzle that he'd made, one of these rectangles, and made it into a puzzle that he could put together and examine. And he left it sitting out, and his mother came along. Okay, what's this got to do with things? Well, she picked up the pieces and put them back together. But there was a little problem, but it was not really a problem. This wasn't the square they started with. She put them together in a different fashion. And that was one of the main things that helped them ultimately find the solution to the problem, because that related to the electrical networks with certain symmetries. And they were able to take advantage of those symmetries and get corresponding squares and make the squared square. Now, I mentioned the monument here, and I also described a squared rectangle in some detail earlier. So what do you think's sticking to this monument here? I don't think I'll say very much more than that. Thank you.
So thank you very much, Ron. Thank you. Ron Mullin is a distinguished emeritus professor. He received his MA degree in mathematics from the University of Waterloo in 1960. It was the first degree granted by the university. In 1964, he received his PhD, written under the direction of William Tutte. From 1967 to 1969, Ron was professor at the Florida Atlantic University and then returned to UW as a professor in the newly formed Department of Combinatorics and Optimization. He's directed 20 doctoral theses, including that of late Scott Vanstone. In the 1980s, along with Scott and Gordon Agnew, Ron was co-founder of the company Certicom, which developed and supplied the security on which BlackBerry used in their phones. He took early retirement from the University of Waterloo in 1996 as Distinguished Professor Emeritus and returned to Florida Atlantic until his second retirement in 2012. In 2001, he received an honorary degree, Doctor Eminat Honoris Causa, from the University of Rostock, one of the oldest universities in Europe. Thank you very much, Ron. Now, it's only in Waterloo, or maybe the Waterloo region, that we can have a public event where we talk about unique solutions and various combinatorics problems and so on and so forth. This is truly a very mathematical region. And now it's therefore my privilege to invite Ken Sealing, Peter Rowe, Dave Jaworski, Barry Verbanovich, Ron Mullin, Ian Goldberg. Sorry to bring you back up. I should have kept you up here, Ron. Ian Goldberg and Dan Younger to join me on the stage to unveil the monument that was installed at the... Okay, so this is not the actual monument / wayfinding post here. This is a replica at almost full size, not quite full size. Is everybody ready? Which way are we looking? Okay. So we look towards the camera. Ready for the... 1, 2, 3. Thank you, gentlemen. So, now I think that we need to have a picture drawn together with the square.
Where is it going to go?
All right. Okay. So, is someone able to help Ron? Sure. Okay. So, thank you. Now, there was a question asked by one of our distinguished individuals on the stage here, and the question was, where is this going to go? Now, you'll notice that there are words on here. There's some big words and there's some small words. The small words explain what squaring the square is all about. The big words look an awful lot like the name of a road. So this is actually going to go on the corner to indicate that this is actually signage so that the taxi company can find its way on campus. All right. Now, you see over here, there are some photos of where this will be placed, and that's you see in the background the buildings around from different angles. All right. So we hope that those who are here today will come by later in the year when the one that's made out of stone, not out of cardboard, will be installed on the corner. So next I'd like to introduce Professor Ian Goldberg. Ian is a professor and university research chair in the Cheriton School of Computer Science, where he is a founding member of the Cryptography, Security, and Privacy Research Group, known as CRISP. He holds a PhD from the University of California, Berkeley, where he discovered serious weaknesses in a number of the widely deployed security systems, including those used by cellular phones and wireless networks. He also studied systems for protecting the personal privacy of internet users, which led to his role as the chief scientist at Zero Knowledge Systems. His research currently focuses on developing usable and useful technologies to help internet users maintain their security and privacy, such as the widely used off-the-record messaging system. He is a senior member of the Association for Computing Machinery and a winner of the Early Researcher Award, the Outstanding Young Computer Science Researcher Award, and the Electronic Frontier Foundation's Pioneer Award. Please join me in welcoming Ian.
Thank you, Stephen. So it's great to be here today. All these current students, former students, faculty, staff are all here to help celebrate the 50th anniversary of the Faculty of Mathematics and, of course, the centenary of the birth of William Tutte. I was very glad to hear about the scholarship that's being named in William Tutte's honor, and I have one suggestion, if I may, that the scholarship should include a bicycle. And you think I'm kidding, but I'm not kidding. I think I'm good. All right. All right. It's really an honor to be here and be able to speak at this momentous occasion. 3 decades ago, the Faculty of Mathematics started expanding into this beautiful building behind you, the Davis Center. The Davis Center opened in 1988, so we started the process of making the building and planning and moving almost exactly 3 decades ago now. Since then, there have been a number of expansions in William Tutte's, albeit at the time hidden area of cryptography. So 2 decades ago, the Faculty of Mathematics formed the Center for Applied Cryptographic Research, or CACR. William Tutte was the honorary director at the time, and that center has been a focus of a lot of related research at the university, mainly in cryptography, but also, as time went on, branching into security, branching into privacy. And it is a place where researchers, not only in the Department of Combinatorics and Optimization, where William Tutte, of course, was a professor, but in computer science as well, and in electrical and computer engineering and other departments. And this was a really good way to have a place for lots of researchers around campus that are working on similar things to have a touchstone to get together. 1 decade ago, the Cryptography, Security, and Privacy Group, or CRISP, as Stephen said, at the University of Waterloo, was formed in the David Cheriton School of Computer Science. We formed as a small group of 3 faculty. We have since grown to 6 faculty members and about 18 postdocs and graduate students and a number of undergraduate student researchers that work with us. And it is a rapidly expanding and extremely successful and popular group at the university. And I'm really glad to be part of it, and it's a great place to work for sure. Fast forward to today. We are now looking forward to make the base built by the CACR and by CRISP even stronger. So we have just started the process, which has taken a long time in the planning, but the official processes have now started to seek approval for a new Cybersecurity and Privacy Institute at the University of Waterloo. So the plan is that this will go to Senate in the next month or so, I believe is the idea, and hopefully we will get approval in short order. And then wouldn't it be great to have the Cybersecurity and Privacy Institute housed in a brand new building on William Tutte Way? So the Cybersecurity and Privacy Institute has even a larger scope than CACR and CRISP. It brings together faculty from all faculties on campus who are working on topics related to cryptography, security, and privacy in the broadest sense. So, for example, not only do we have the, of course, extremely well-known cryptographers over in combinatorics and optimization working on things like post-quantum cryptography. That's cryptography that's secure even against the quantum computers that our friends over in IQC are busily working on making. It has people over in computer science working on things like censorship resistance in order to provide tools for people around the world who live in countries where the internet is censored to nonetheless access free and open internet content and communicate freely. We have people working on information theoretic cryptography. That's cryptography that remains secure even if you have something beyond a quantum computer. The most powerful computer you could even imagine would be unable to break information theoretic cryptography. It has people working over in applied health sciences over that way who work on the security and privacy of health-related data and electronic health records. It has people from the arts faculty out that way who work on the social aspects of privacy. All these researchers will be coming together as part of this Cybersecurity and Privacy Institute. And I am really excited about the prospects going forward. So in the 50 years of the Faculty of Mathematics and indeed of the School of Computer Science that have passed, and in the decades going forward, I hope that William Tutte's legacy carries on in these new opportunities for faculty and for research, and as a central point for which people from the outside can look at Waterloo and say, this is something that Waterloo is the world leader in. Thank you.
Well, thank you very much, Ian, for that inspiring portrayal of a direction forward. We're happy to be charging down that road. That's a different road. Okay, so I'd like to thank everyone who has come out here today. There's more to go, more to come, and so we won't linger. But before we break up here, I'd like to present some special thanks to Ron Mullin, Bill Cunningham, and of course Dan Younger. So thank you. Also, thank you to the committee that helped to organize today. Barry Ferguson, Ricardo Fukasawa, Amy Aldis, Candice Harrington, as well as Anna Freitas and the Math Hawk team who organized the scavenger hunt. Special thanks to Melissa Muxulis for her assistance in stewarding the Moment project. My thanks for our fantastic volunteers here today, all ably led by Alex Farley. Where's Alex? Is Alex here? Okay, he's all right. And special thanks to the audience for taking your time out of your schedule to be here today, to spend a few moments to remember this man who never asked for accolades, but who richly deserved them. Finally, I would like to encourage the students in the audience to stay inspired and to go forward and to build on Tutte's legacy, to build your own legacy, and to have those together build the legacy of this city. A few reminders before you head off. The documentary Code Breakers, Bletchley Park's Lost Heroes will be taking place immediately following this in DC 1302. That away. All right. If you're unfamiliar with our campus, you'll find volunteers outfitted in math pink. Okay, I think we can call them pinkies. So you'll see folks in Math Pink. They'll lead you over there. It's a great movie. For those who knew Tut, you knew that he was a great lover of games. As such, Anna Freitas and the Math Walk team have organized a scavenger hunt to be hosted right here in this tent. Now, many people have heard of Math Sock, but not many people have heard of Math Falk. So for people who are in the faculty here, I'm not being rude. This is the Faculty Orientation Committee. Okay, so if you have any questions for today's presenters, they can stay around for a little while, and you're free to come up and say hello. But with that, I thank you and close this event.